Let's write a Python program. I have suggested a name for it, and that is traps.py. So starting from Python program, we have to define the value of NA and the B value. But before that, let's define the function that we are going to use in the program. So I define f of x, and from f of x, I would like to calculate a value. So I say fb, and that will be equal to 1 minus x squared value. And upon the completion of function, I must get the value of fb variable. So whenever this function is called, it will return the value stored in fb, and function will be called with the name f. Now let's define for this function, let's say a equal to 0, that was the starting point, then b equal to 1, and let's define n equal to number of points. So from 0 to 1, if we divide into 5 subintervals, then n will be equal to 6. So let's define n equal to 11, the number of points. So it will include 0 and 1, and also the number of steps or intervals would be 10. That is one less than that. Now let's define the another variable for the integral. So it is going to be a summation calculation. So I say sum trapezoidal. That is the variable for storing the answer for the integral. So let's begin the algorithm. So the first value that should be stored in trap should be f of a. So I say f of a. So that will be computed over here. And also we require the final value that should be added to that. So let's add f of b also to here. So the two values have been added in the trap summation. Now in the summation form, we can write, well, we have not defined x value and not h value. Okay, let's define the h value. So h value will be equal to b minus a divided by n. So that is the h value. Now let's develop the data points value, interior points, which are separated by h. So let's define a dummy variable x, and now we are ready to write in the algorithm. So for I in range, so let's take the values of I from 1 to n minus 1. So of course n minus 1 value would be equal to 10, and I defined x value equal to a plus I times h. So when the I value is equal to 10, so hopefully we will have the n plus first point. Mhm. And then let's update the sum value. So grab value plus f of x. That is going to be the interior part. And in the summation, we require for all interior points, we require the twice of these values. So interior part of summation has been computed. So finally, the last value would be trapezoidal will be the b minus a over b minus a divided by 2 asterisk n and times the summation. And finally, I can say print the answer of trapezoidal rule for that integral would be this one. Okay, so it's time to run the program. Which should be saved and run. And let me show you the answer. So the answer is 0.649511. So that is the numerical integration of the function and its algorithm that has just been programmed in front of you.